To my YouTube channel. In this video lecture, we are going to see how to solve revision questions from Oxford General Navigation book. So let's start with question number 1 for today, which is question 141. What is the shortest distance between points A and point B? Points A and B. Now point A is 35 degree 43 minutes north, 8 degree 41 minutes east. B is 54 degree 17 minutes north and 171 degree 19 minutes west. So the shortest distance between them. Now you will observe here that 171 degree 19 minutes plus 8 degree 41 minutes is equal to, the sum of them is equal to 180 degree. That means these locations are located on meridian and anti-meridian. Now meridian and anti-meridian together form one great circle. So you will fly a great circle track between point A and B, and this great circle will pass across the North Pole. Okay. So let's draw the diagram. There will be two diagrams I will show you. So first diagram will be this one. So this is your Earth. Okay. You are looking at this Earth from the North Pole. This becomes your prime meridian. This becomes 180 east and 180 west meridian. This is your 90 east. This is your 90 west. Location A is 8 degree 41 minutes east. So 8 degree 41 minutes east will be somewhere here. The second location is 171 degree 19 minutes west. So 171 degree 19 minutes west will be here. So both are located amne samne, in front of each other. That is meridian anti-meridian, like this. So this is the great circle track. This is meridian. This is anti-meridian. Okay. And so you will start from A. This is your A. This is your B. So your aircraft will fly from A to B following this great circle track, like this. Then it will pass the North Pole, and then it will go to other side of the hemisphere, other side of the Earth, which is Western Hemisphere, and then go to point Bravo. Okay, then go to point Bravo. So this will be the path. So now we have to find the shortest distance between them. So now draw the second diagram, which is this one. This is your North Pole. Okay, Western Hemisphere latitude is what? Now here plot the latitudes in this diagram. 35 degree 43 minutes north, the West Hemisphere, and 54 degree 17 minutes north, in the Eastern Hemisphere. Now we have to find the shortest distance between them. This diagram is used to prove that uh, the plane is going to fly great circle track because both points are on meridian anti-meridian. To find the distance, you will use this latitude diagram. So distance between point A, B, okay, A is 35 degree, the distance between A and B is equal to, first, this distance between the North Pole and 35 degree 43 minutes north. Okay, this distance. That is 90 degree minus 35 degree 43 minutes plus this distance 90 minus 54. 90 degree minus 35 degree, which is 54 degree 17 minutes. This is 35 degree 43 minutes. Okay, so 54 degree 35 degree 43 minutes plus 54 degree 17 minutes is equal to 90. Okay, this is 90 degree. So great circle distance will be d lat into 60. Now difference between both latitude is 90. Multiply by 60 is 5400 nautical miles. So the correct option will be option A, 5400 miles. Next, question 142. On a conformal chart, the two parallels are 41 degree 20 minutes north and 11 degree 40 minutes north. What is the constant of the cone? Okay, so constant of the cone is nothing but your sine latitude. Over here, the latitude is nothing but your parallel of origin. Parallel of origin. Now, this is your Earth. Okay. Lambert's cone is this. Okay. It will touch the Earth at 2 points. Over here and here. Okay. So the two standard parallels are 41 degree 20 minutes north, 41 degree 20 minutes north, and 11 degree 40 minutes north. Okay, the mid latitude, which is the parallel of origin, will be in the center. So that will be the mean. So you have to add both of them. 41 degree 20 minutes plus 11 degree 40 minutes divided by 2. So 26 degree 30 minutes. This is your parallel of origin, the mid latitude. Okay. So the latitude that you are going to use here is parallel of origin latitude. So it will be constant of cone will be sine of parallel of origin is 26 degree 30 minutes. So sine 26 degree 30 minutes is equal to 0.446. 0.446. So option C is the correct option. Runway direction is given to you. Winds are given to you. What is headwind component? So headwind component is equal to wind speed into cos theta. Now here theta is nothing but your wind direction minus runway direction. Wind direction is 0.45. Runway direction is 0.83. So 45 minus 83 is minus 38. Wind speed is 35 knots into cos minus 38. 35 into cos minus 38 is 27.5. Okay, that is 27 knots. So correct option will be option Bravo. Okay, 27 and a half knots. Minus sign denotes headwind. Question 144. True airspeed is given, track is there, winds are there, what is heading and ground speed. The task is 375, wind correction option. Task is 175, force is 335, wind direction 34050. So true heading is 336 and ground speed is 325. Okay, so select that option which has these two values or any other value which are closer to this. Okay, next. Lines of latitude on a chart are always great circles, small circles except for the equator, vertices, meridian. So all parallels of latitude are rhumb lines. Okay, all parallels of latitude are rhumb lines. Only equator is a great circle and a rhumb line. Both great circle and rhumb line. Okay, and all latitudes other than equator are called small circles. Other latitudes will be called small circles because it cannot be a great circle, so small circles. So correct answer is option bravo. Lines of latitude on a chart are small circles except for the equator, which is a great circle. On a Lambert chart, the convergency factor is given to you. What is the parallel of tangency? Now, parallel of tangency is nothing but parallel of origin latitude. In the previous question, somewhere here, yeah, we were given two latitudes. From those two latitudes, we found parallel or parallel of origin, this mid latitude, and from that we found, okay, from that we found this constant of the cone, okay, which is convergence, constant of the cone. Now, in this case, the reverse will happen. We have been given convergency factor, okay, so we have been given constant of the cone or convergency factor 0.78585, right? And that is equal to sine of latitude, sine theta, where theta is the parallel of origin. Okay, so now theta will be equal to sine inverse 0.78585. The sine inverse 78585 is 51.79 or approximately 52 degree. Okay, approximately 52 degree, 51 degree. So accurate answer is 51 degree 47 minutes. Okay, so parallel of origin is 51 degree 47 minutes. So option delta will be the correct option. Okay, so first again, the convergency factor is nothing but sine theta. Now theta is your parallel of origin latitude. So do the inverse using shift sine inverse and you get the latitude value. On a Lambert's chart, the constant of the cone is 0.8. Again, sine theta they have given 0.8. Point A is at so and so. You fly to point B. The initial Lambert's chart straight line track is 070. Rhumb line track is 080. What is the longitude of D? So we'll use the formula. convergency equals to d long into sine latitude. Okay, we will use next. Great circle track is 070. Line track is 080. Now the difference between great circle and rum line is convergency angle, which is 10 degree. If convergency angle is 10 degree, convergency will be 20 degree, double of that. So we'll put 20 here. D log as it is. Sine latitude is 0.8 convergency. So D log will be 20 divided by 0.8, 25. Okay, so difference between two longitudes is 25 degree. Initial longitude is 4 degree west. Okay, initial longitude is 4 degree west. So you are going from A to B in the direction of east. Okay, you are going from A to B in the direction of east. A is 4 west. Now when you travel easterly direction from a western location to east, from western location you travel easterly direction. What happens to longitudes? The longitude value will decrease so long you are in the western hemisphere. Once you cross prime meridian and enter eastern hemisphere, the values will again go on increasing. So over here, D long is 25 degree. So D long is 25 degree. That means there will be a prime meridian in this picture. Point A, prime meridian, point B. So A, difference between prime meridian and location A is 4 degree. The difference between point B and prime meridian will be how much? 21 degree. And the total difference between them is 25. So the location of point B should be 21 east. 21 east. Option A. Simple. On which chart projection is it not possible to show the North Pole? Is it direct Mercator, Lambert's, transverse Mercator, polar stereographic? So answer is direct Mercator chart. You are at flight level 150 where temperature is -5. You are over an airport with an elevation of 720 feet. QNH is there. Assume 27 feet is 1 millibars. What is your true height? Simple altimetry question. I have done similar questions in the different altimetry videos that I have done and uploaded it in the YouTube. So do watch that videos also. Over here, let's draw the diagram. Elevation of airport is 720 feet. QNH is your standard pressure setting datum. QNH is 1003. Standard pressure setting is 1013. Elevation is always measured from mean sea level, 720 feet. Okay. What will be the, and then your aircraft is at flight level 150. Flight level is measured from standard pressure setting datum, 15,000. We have been told to find true height. Okay. That is height of aircraft above the ground, above this surface. Okay. So now this true height is nothing but this entire thing minus this value. Out of this we know this much is 720. Let's find this value. So how to find that? pressure difference between them is 10 millibars. So height difference between them will be 10 into 27. 1 millibar is 27 feet, so 270 feet. So this is 270. Total becomes 270 plus 720, 990. 990. So height of aircraft will be equal to 15,000 minus 990, 14,000 feet. 14,000 and 10 feet. Now we have to use this temperature also. Now this height that we have found is with respect to pressure error. Now we have to we have to consider temperature correction also. Now what should be the outside air temperature? Outside air temperature is minus 5. ISA temperature at 15,000 feet is 15 minus 2 into 15, 15 minus 30, which is minus 15 degree Celsius. So ISA temperature should be minus 15, but currently it is minus 5. That means it is warmer by 10 degrees Celsius. ISA deviation equals to outside air temperature minus ISA. So minus 5 minus of minus 15. So minus 5 plus 15, which is 10 degree Celsius. Now use the formula temperature correction equals to 4 degrees Celsius into ISA deviation into per 1000 feet. So 4 into ISA deviation is 10. 1000 feet. 15,000 feet, so multiply by 15. So 4 into 10 into 15 is 600. Now you are going to add this 600 here to your true height. So your final answer becomes 14,010 plus 600, 14,610 feet. Okay, so approximately option Charlie. The closest option is option Charlie. Next, what is the formula for convergency angle? It is convergency divided by 2. So change of longitude to sine of latitude is convergency, not convergency angle. Change of longitude into cosine latitude, there is no such formula. Change of longitude divided by 2 into sine mean longitude, that is wrong. So option C is right. Change of longitude into sine of mean latitude, the whole divided by 2. So this is the formula. With this we come to the end of this lecture. I hope you have understood all the questions that I have solved here. Let me know if you have any doubts or comments. With this, I also request you all to subscribe to this channel, share this video with your friends so that they also may know about these lectures and like this lecture.